Hello students, we are going to start a new chapter today. I hope everyone is doing fine. So the name of the chapter is triangles. I know you have a brief idea about this topic. So let's not waste our time and let's start the chapter. So what do you mean by a triangle? A triangle is a closed figure made up of three straight lines. They are having three sides, that is in the name itself, in the name of the triangle itself, it says that tri means three. So the figure having three sides is called a triangle. So a triangle has three sides. First of all, three angles. So in a triangle, it has three sides, three angles and three vertices. Vertices means the point where the angles are formed, where the two sides collide with each other. So meet with each other. So they have three sides, three vertices and three angles. So in this example, let's say this is a triangle. So this is A, B, C. So in triangle ABC, the AB, BC and AC are the three sides. Then angle A, angle B, angle C are the three angles, and ABC are the three vertices. So this is about the triangle. Now let's proceed to the chapter. So first of all, what is congruence of triangles? In this chapter we will give more light to this topic, congruence of triangles. So what is congruence of triangle? What do you mean by congruency? Congruency means any two things that are having the same shape and same size. For example, two copies of your photographs. The photographs that you have, for example, the passport size photograph. The passport size photograph, they have the equal size and the equal shape, right? So they are said to be congruent. Similarly, two bangles of the same size, the bangles that you or your mom wear, they are of every bangles are of her size, right? They don't seems to be that one is very bigger in her wrist and one is very small. No, that is not possible. So your mom wearing the same size of bangles, they are also said to be congruent. Two ATM cards are also have a specific size, so they are said to be congruent of the same bank. So what are the various rules of congruence of triangles? So in triangle also, if two triangles have the same size or say same shape, the triangles are having same shape obviously. If they are of identical in nature, means if they are having the same size, then they are said to be congruent. So we have some specifications. With that we can say that whether the triangles are congruent or not. We have some rules. Okay. So first one is your SAS congruence rule. SAS means SAS. S means side. This is your angle and this is your side. So side angle side rule. Side angle side means any two sides. Say this is your A, B, C and this is your D, E, F. These two triangles are given. Say here your two sides are equal. AB equal to DE. Means this side is equal to this side. Similarly, BC is equal to EF. This one is equal to this and angle B is equal to angle E. So if these parts are equal, then we can say that these two triangles are congruent on the basis of side angle side congruence rule. Means in side angle side congruence rule means the two sides of a triangle should be equal and an included angle. Say these two sides are equal, so this angle must be equal. if we say that these two sides are equal and these angle is equal, no, then we can't say that this two triangle is congruent. So we should always remember that the included angle, everyone has a doubts in this part. So everyone commit mistakes in this part, that they say AB so AB is equal to DE and BC is equal to EF and angle C is equal to angle F. So this angle is equal to this angle. Then we can't say that these two triangles are congruent. The included angle means if these two sides are equal, then these angles should be equal. Okay. Now the next part is side. That is very easy. Means the three sides of both the triangle should be equal. This A, B, C, D, E, F. So AB should be equal to DE. AC should be equal to DF and BC should be equal to EF. If the three sides are equal, then we can say that the two triangles are congruent on the basis of SSS congruence rule. Now the next one is ASA. ASA means the SAS, it is similar to SAS. How? ASA means two angles and the included side. Let's say this is A, so let's say this angle A is equal to angle D. So angle A is equal to angle D. Same angle B is equal to angle E. So here two angles are equal. So this should be equal. So AB equal to DE. So these three, if these things are satisfied, if two angles and the included side are equal, then we can say that these two triangles are congruent on the basis of ASA congruence rule. So in ASA congruence rule, two angles and one side should be equal. Then another one, that is AAS congruence rule. Here two angle and any side and one side should be equal. So for this rule you have to take one included side, but for this rule any side can be equal. So if we say that angle A is equal to angle A is equal to angle D, angle B is equal to angle E, and if we say AC is equal to DF, then also we can say that these two triangles are congruent on the basis of AAS congruence rule. Now the last one, that is the RHS congruence rule. So it is for the right angle triangles. So for the right angle triangles, what does it stand for? This is your right angle, this is your hypotenuse, this is any other side. So in two right angle triangle, you know that the one common part is the right angle. In any right angle triangle, they have one angle, that is right angle. So any angle, there will be one angle in right angle triangle, that will be 90 degree. So here one angle is there. Second part is the hypotenuse, means this longest side of the right angle triangle. These two sides should be equal. Means this, let's say this is A, B, C, D, E, F. So this AC should be equal to DF. Then side means these two sides are remaining. So from this to any one side can be equal. If these three are satisfied, then we can say that these two triangles are congruent on the basis of RHS congruence rule. So these are the 5 rules of congruency that when used we can say that the triangles are congruent. Now let's come to the axiom 7.1. So 7.1, this all things are discussed in your theorems and axioms, but I have given a brief idea about it. So first of all is the axiom 7.1. What does it say? SAS congruence rule. Two triangles are congruent if two sides and the included angle of one triangle are equal to the two sides and the included angle of other triangle. Means, let's say two triangles are given. This is A, B, C, D, E, F. So two sides and the included angle means AB is equal to DE and AC is equal to DF, and the included angle, say angle A equal to angle D. So if these are equal, then we can say that these two triangles are equal on the basis of SAS congruence rule. Now let's solve one example. Here they have said in figure OA is equal to OB, means OA, this is your A, this is your A. So OA means this one is equal to OB, then OC is equal to OD. We have to show that triangle AOD, means AOD, this triangle is congruent to this triangle BOC, and also we should show that AD is parallel to BC. Now before coming to this question, let me tell you another thing, that if two triangles are equal, suppose we have used one rule and we have proved that two triangles are equal, two triangles are congruent, So if we say that in two triangles, that is A, B, C, let's say that here they have already told us that AB is equal to DE, BC is equal to EF, and angle B is equal to angle E. So by SAS, right, AB is equal to DE, BC, DF, and angle B is angle E. So by SAS we can say that these two triangles are congruent. This is the sign of congruency. So these two triangles are congruent. But the remaining parts, what happens to the remaining parts? Remaining parts means this side is remained AC and DF, and here angle A, angle D, angle C, angle F. So what happened to these remaining parts? They will automatically become equal to each other, and these things are called CPCT. What do you mean by CPCT? Corresponding parts of congruent triangles. Corresponding parts of congruent triangles. By CPCT we can say that the remaining parts of the triangles are also equal. So let's solve this question. What are they given? Given is OA equal to OB, OD equal to OC. We have to prove one is triangle AOD congruent to triangle BOC, and second is your AD parallel to BC. Now proof. In triangle AOD and triangle BOC. So in these two triangles, what are the equal parts? OA is equal to OB, OC is equal to OA equal to OB, OD equal to OC. Yes. So these parts are equal. Now we can say that this angle is equal to this angle. This is the included angle, right? If we say that these angles are equal, we can say these two triangles are congruent. So this angle is equal to this angle. How? They are, this is AOD equal to angle BOC. How? Because they are vertically opposite angles. So we have got two sides and one included angle equal. So we can say that by SAS congruence rule, triangle AOD is congruent to triangle BOC. So we have proved the first part. Now the second part, see AD parallel to BC. Since these two triangles are equal, we can say that the remaining angles are also equal because they are the corresponding parts of congruent triangles. So here angle OCB is equal to angle ODA and angle OBC is equal to angle OAD. So but see, they are like this angle and this angle. They form a pair of alternate interior angles, right? They are, see, if these two lines we take and this is as a transversal, then these two are equal. Since these two alternate angles are equal, we can say that these two lines are parallel, right? So we can say, but they forms a pair of alternate interior angles. So AB parallel to CD. So hence proved. So we have proved it. First of all, we have proved by using the vertically opposite angles axiom. We have proved by that by SAS congruence rule these two triangles are congruent. Since both of them are congruent, the corresponding parts, here we should write the reason, by C, P, C, T are equal. So they form a pair of alternate interior angles. So AB parallel to CD, hence proved. Now see, next question. Next example, AB is a line segment and line L is its perpendicular bisector. Perpendicular bisector means these two angles are 90 degree, and bisecting means these two parts are also equal. We have to prove that P is equidistant from A and B. P is equidistant. Equidistance means equal distance. The distance between P and A and the distance between P and B is equal. We have to prove. Means in short we can say that PA is equal to PB. We have to prove it. So let's write the given. So given is line L is perpendicular bisector of AB. So, we have to prove P is equidistant from A and B, that is PA equal to PB. So, this is your given part. Now, the proof. Now, in the proof, say in triangle PAC and triangle PBC. Why we are taking these two triangles? If we somehow prove these two triangles to be congruent, then we can say the remaining parts are also equal. So, we can say that this side and this side is equal. So, if we are saying that these two sides are equal, then the thing that they have asked to prove will be proved. So, in these two triangles, what are the equal parts? See, first of all, AC is equal to CB. Why? Because this PC bisects AB. Means this line is bisecting these two, so we can say that this part and this part is equal. Now, next is your angle. Angle PCA equal to angle PCB. Why? Because both of them are 90 degree. Now see, these are right angle triangles, but here the hypotenuse are not equal. They are not equal, they are not mentioned to be equal. So if it is not mentioned, then we can't use that RHS congruence rule, because in RHS their hypotenuse should be equal. So here these two are equal. Now last part, this PC, see this PC. PC is common in both the triangle. So this is your common side. So by SAS congruence rule, triangle PAC is congruent to triangle PBC. So, therefore, PA is equal to PB. Why? This is by CPCT. So, we can say that is P is equidistant from A and B. So, we have proved this part. So, this was a very easy question. Now see theorem 7.1, ASA congruence rule. So two triangles are congruent if two angles and the included side of triangle are equal to two angles and the included side of other triangle. Means they are congruent if these things are equal, they have said. So we are having this equals and we have to prove that these two triangles are equal. Now let's prove it. So for this we have what are the given? Let's say two triangles are given, A, B, C and D, E, F. D, E, F. So they have given us that angle B is equal to angle E, angle C equal to angle F, and one of the side, that is AB, is equal to say DE. These three things are equal. Which one they have said? B and E, C and F. No. So also BC equal to EF. They have given. We will take this as given and we have to prove. What do we need to prove? We have to prove triangle ABC congruent to triangle DEF. Now in the previous theorem, previous exam, they have said that two triangles are congruent if two sides and an included angle is equal. So there is one angle given, this side is also equal to this side. So if we take this side equal to this side, then we can say that these two triangles are congruent. So we are taking two case study, two case, okay. So first of all, case 1. First of all is case 1. Let AB equal to DE. So if AB equal to DE, angle B is equal to angle E and also BC is equal to EF. So these two are given. So by SAS congruence rule, you can say that triangle ABC is congruent to triangle DEF. This was our first case. Now in the second case, we will take AB is greater than DE. So there are the two triangles. In these two triangles, the case 2 is your AB is greater than DE. Let AB is greater than DE. So we will take a point P here such that your BP is equal to DE. We will take a point P here. Why we are taking a point here? See, we have said first case, we have said that AB is equal to DE. In that case, we can say that these two triangles are congruent. But we can't say it clearly, right? They have not mentioned it. So we are just using some case study. We will take three cases. First one, we will take that this side are equal. Second case, we will take that AB is greater than DE. And in the third case, we will take AB is smaller than DE. So since here AB is greater than DE, means there will be a one point from where this side will be equal to DE. So we have taken this point P. So here a point P is taken on AB such that PV is equal to DE. Okay. Now since PV is, we will take in triangle PBC and triangle DEF. So here PB is equal to DE. Also angle B is equal to angle E. Also BC is equal to EF. So BC equal to EF. Now see, here also by SAS we can say these two triangles are congruent.
minutes हुआ
और 5 मिनट लगेगा. एक सेकंड पॉज कर दीजिए तो. हेलो क्लास कर रहा हूँ तो ना. हाँ दे दीजिए. पॉज नहीं है. अच्छा. So by SAS these two triangles are congruent. So since these two triangles are congruent, you can say that angle PBC is equal to angle DEF. That thing that we have taken here. Also we know that ABC is equal to angle DEF, and we know that AB equal to DE we have taken, and also PB equal to D. So from this all things can be possible only if this P is coincide with A. These things are only possible if this P is. So these things are only possible if this is only possible if P coincides with A. So from this part we can say that AB is also equal to DE. So from all these things we can another case is there. In case 3 will be let AB smaller than DE. So in this part also similarly this case will prevail and this point will be there. So from all this thing we can say that two triangles are congruent if two angles and the included side of one triangle is equal to the included side of other triangle. So this was the theorem. So from that part we got another congruence rule, that is two triangles are congruent if any two pair of angles and one pair of side are equal. Means you don't have to take the included side. We like these two triangle, in these two triangle A, B, C and D, E, F. If we say that this angle and this angle is equal and this one is equal to this one and this side is equal to this, means BC is equal to EF. The included side we didn't mention here. This is not included side, but that part in that time also we can say that these two triangles are congruent by AAS congruence rule, that is your angle side. Now the last example of this class. This is a very short one, very easy one. So here your given is AB is parallel to one line segment, that is CD. AB parallel to CD is given. and O is the midpoint of AD, means O is the midpoint of AD. So OA is equal to OD. So this is your part. We have to prove one is your triangle AOB congruent to triangle DOC, and another one is O is also the midpoint of BC. Means this is the midpoint of this line. We have to prove that this one is also the midpoint of BC, that is OB equal to OC. We have to prove it. This is very easy question. You can do it in your own also. Just see, in triangle AOD and triangle AOB and triangle COD and triangle COD. What are the things that is given? AO is equal to OD. This is given. Also, you can say that this angle is equal to this angle. Why? Because they are parallel line. So, angle ABO is equal to angle OCD, that is your alternate interior angles, because AB parallel to CD. So this angle is equal, this side is equal, and another, this one is also equal to this one. Angle OAB is equal to angle ODC. This one is also alternate interior angles. So two angle and one side are equal, means by AAS congruence rule, these two triangles are congruent. So since these two triangles are congruent, we can say that this part is equal to this part, means OB is equal to OC. Why? By CPCT. So since these two are equal, we can say that is O is also the midpoint of BC. So this way we have proved it. So this was the last question of our class. Till then, take care. We will meet in the next class.